formulation 7. So basically, for the purpose of your exercise, you either choose homogeneous volatility for table 5, or you choose this last guy, parametric homogeneous volatility. That's your formulation 7. Play around with other options if you want. See how the fit changes. I'll show you how to look at the diagnostics after we're done with model setup. I mean, this is mostly it. Shift type, I'm not going to get into because I'll actually come back to it after the lecture, because I'll explain to you what shift means. Stochastic volatility object looks very similar, except you add a couple of additional options here in terms of what kind of stochastic volatility type you want to have. So we choose CIR flat, the stochastic volatility reversion. So this creates a more complicated model. You don't have to use this object. This is there for you to play around to see what a lot more powerful model could do if you wanted to. This is a lot more powerful model. But for a lot of purposes, especially as, again, I'm jumping ahead to today's lecture, if you're only fitting at the money term structure, this model should be enough, even without shift. You need shift and especially stochastic volatility components if you are trying to fit not only at the money caps and swaptions, but also the whole money nets I mentioned. And again, you'll see that if you're lecture. So next, we're going to the instrument setter. So what are we calibrating with? Well, first of all, we try to set it up as clean as possible for you. So even though the models are configured here, you have an easy drop-down menu here in terms of which model to use. You can either go with shifted LMM or shifted stochastic volatility LMM. Okay, and then the whole thing will automatically pick up either this object or this model object. Okay, this is for your control. Now, let's say we're going with the simpler one, with this guy. The instrument collection is specified in here. This is where you input your instrument. So what I have here, I have manually typed in 30 different swaptions. And this is, again, conveniently set up so that all you have to do is provide the tenor of the option and the swap tenor and say that it's at the money or provide the strike price. And then the rest of the formulas here will automatically pick up the data from this input, from this big matrix. We just made it easier for you so that you don't have to manually input. You can look through the formulas and try to understand how this works, but we made it easier for you. So then we'll automatically feed the data from there in here and create the right kind of object. In fact, if you try to visualize what you have created, you can see there's a little macro that hopefully still works after I messed with it, that basically what it does, it picks up the option tenors and swaps that you have entered and shows you which elements of the matrix visualizing for you have selected. Because your full input is this whole matrix, as you saw, right? On this sheet, I gave you everything 30 by 30. You're not going to calibrate to 30 by 30 is how much? 900 instruments. That's a lot, right? You probably don't want to do that. Although you can try. I mean, you can extend it to see how much it can handle. You can play with it. But here, we only chose 30 out of 900 swaptions. And this is the pattern that we chose. You can play around with your choice. Okay, you can try to load exactly the 10 by 10, for example, that is in the homework. I'm sorry, not in homework, but in the MATLAB part, just to get better correspondence, okay? See how it fits, which is probably what you should start with, frankly, if you're trying to get comparable results. But you might need to expand this guy further down. So, I mean, it's your worksheet. You play with it, okay? We try to give you something that works, something that is a working template for calibration, and then you take it as far as, you know, your imagination allows you to. Now, that's the swaption feed. Once you're done with swaptions, you can also specify caps if you want to use them. Now, notice that I only have one cap here listed. The reason I have only one cap here listed is because Numerix actually hates calibrating to caps. It just doesn't. Numerix calibrates to caplets. So what it does, it basically says, if you want me to calibrate to a 10-year cap, you're basically asking me to calibrate to every caplet inside that cap. So the longer, so I don't think, as far as I know, I don't think there's an easy way of telling Numerix only calibrate to 5-year caplet and 8-year caplet. The only options are basically calibrating to all caplets from 3 months all the way to X, maturity T, okay? So I put 10 years, and as you will see, you can see in the object, oh, let's see, I guess I set up 2 redundant object viewers. So when I click on Numerix tab, when I click on ID of an object, it will show me what's inside the object if I click Object Viewer. And that's not what I was looking for, so hold on, there's instruments. There we go. So this object contains the results of the calibration, or this calibration. So you can see that the instrument type is listed here, and you can see all my 30 swaptions. But then, at some point, you pick up caplets. That's what it's calibrated. You can see what's inside the calibration set. The next column, and because I said 10 years, 10-year caplet, you're probably going to have, 40 caplets. You have maturity column here telling you where it matures. Okay, so makes sense. See, it ends June 2021, and this is 2011 data. Okay, so it's 10-year caplet. So you can look through these columns, and they're pretty self-explanatory. This is the value that your model tells you it's worth, and this last column actually is the market input. So from this object, what we did was we created these 2 views for you, which you're welcome to customize to your liking. But this is in sample fit of the first 30 swaption instruments. This is how well this model fits. So the blue is the volatility, which is market volatility, and the red is the fitted value. So at the short end, we're having some problems fitting with this model, but longer end fits a lot better. When you go to this guy, caplet, I'm building the same picture for caplets. So you can see how the caplet fits compared to mine. What else am I going to tell you? disregard this guy because this guy is supposed to produce the fitted implied volatility value. And it is indeed the fitted implied volatility value for swaptions. But for cap, because Numerix does not calibrate to caps, it calibrates to caplets, what it's going to put in here is implied volatility for the first caplet. So it's not going to match up to cap implied volatility for 10 years cap on the market. So it's not going to look right, which is why I had to build a separate tab to show how caplet implied volatility matches market caplet implied volatility. So this is why we needed to separate them, because you cannot use the same convenient command setup depending on whether it's a swaption or a cap. That's why you have two separate plots. The picture here we started kind of showing you what the out-of-the-money instrument fit looks like. So you build, again, using similar formulas, you create three instruments that are out of sample, which means that they were not included for calibration here. And you can ask yourself a question, how well are you capturing these swaptions, 6-month maturity and 5-year swap tenor and the other two, how well are you capturing their pricing? And here you can see the out-of-sample pricing fit. You can see the pricing error in terms of implied volatility. So the little graph here kind of plots it for you to show you graphically how much pricing error you have. In this case, the pricing error is in dollar terms, actually, not in terms of implied volatility. This is built using dollar error, which might or might not be what you're looking for. You can think about how to build similar report in terms of implied volatility difference. I mean, it should be fairly straightforward to do. But this is an example of how you pull the dollar value of the contract. So this compares the so the object is inside F. So see, I pulled up this particular swaption. You can see all kinds of information about the swaption buried inside its object. They even calculate various Greeks for it and price, etc. So play around with it. Really, you can see that it's a fully functional setup. Like I promised you, we're not going to be harsh grading it, this section, but because it's already working, you can always, it's easier to play with. I mean, if you want to add a new swaption, if you want to add a new column, if you want to build some new viewer, there is another tab I did not talk about. This is an additional viewer tab we set up. This one is, you can monitor 3 things from this viewer. This is the viewer for the LIBOR market model itself. It shows you the parameters. So it gives you the time grid here. This is more advanced feature. I don't even fully understand how this thing works, but it has to do with how the coupon day fractions, it's how they get approved. This is flat volatility guide. This is your psi I parameter in table 5. So